Hello everyone, and welcome to ZoomInData. In this video, we will explore the architecture of Azure Data Factory, one of the most powerful cloud-based data integration services. Understanding the architecture will help you design pipelines more efficiently, troubleshoot issues, and make better use of ADF features. Let's start by looking at the big picture of how ADF works. Azure Data Factory is a fully managed cloud service that allows you to integrate data from multiple sources. It is not just a data mover, it orchestrates and automates complex pipelines. ADF supports both ETL, where you transform data before loading, and ELT, where you load first and transform later. It can connect to cloud sources, on-premise systems, databases, and more, making it extremely versatile for modern data workflows. Understanding ADF's architecture is crucial. When you know how its components interact, you can design pipelines that are efficient, easier to maintain, and cost-effective. It also helps in troubleshooting failures quickly and scaling pipelines as your data grows. Without a solid understanding of ADF architecture, building large or complex pipelines can become challenging. Azure Data Factory is built from several core components that work together. Pipelines are the main containers for workflow orchestration. Activities define what happens inside a pipeline, like copying or transforming data. Datasets represent the data you are working with. Linked services connect to external sources, like a database or blob storage. Integration runtimes are the compute infrastructure that executes your pipeline tasks. In the following slides, we will explore each component in detail. A pipeline is like a workflow container. It groups multiple activities that need to run together. For example, you might have one pipeline that extracts data from a database, transforms it, and loads it into a data warehouse. Pipelines also allow you to set triggers and schedules, so your tasks run automatically at specific times or in response to events. Activities are the building blocks of pipelines. There are two main types: data movement activities, which copy or move data between sources, and data transformation activities, which modify or process data. Common examples include copying data from blob storage to SQL warehouse, executing a Databricks notebook to transform data, or running a stored procedure in a database. Activities are the building blocks of pipelines. There are two main types: data movement activities, which copy or move data between sources, and data transformation activities, which modify or process data. Common examples include copying data from blob storage to SQL warehouse, executing a Databricks notebook to transform data, or running a stored procedure in a database. Linked services act as connections to your data sources and compute environments. For example, a linked service could connect to a SQL Server database, an Azure Blob Storage account, or a REST API. You can reuse linked services across multiple pipelines, which makes managing connections simpler and more consistent. Integration runtime is the compute engine that executes your pipeline activities. There are three types: Azure IR, which runs in the cloud, self-hosted IR, which runs on premises, and Azure SSIS IR, for running SSIS packages. Integration runtimes handle the actual movement and transformation of data and are critical for performance and scalability. Triggers automate when pipelines run. You can use schedule triggers for regular intervals, tumbling window triggers for batch processing, or event-based triggers that react to events like a new file arriving in storage. For example, you can set a pipeline to run every night at 2 a.m. to process daily sales data automatically. Parameters allow you to make pipelines reusable. Instead of hard-coding values, you pass them at runtime. For example, you could parameterize the file path or date range in a copy activity. This makes your pipelines flexible and easier to maintain across multiple datasets or environments. Monitoring is critical for reliable pipelines. ADF provides a built-in dashboard where you can track pipeline and activity runs, view metrics, and check logs. You can also set up alerts for failures so you can respond quickly. Effective monitoring ensures your data workflows are robust and maintainable. Here's a practical example. Suppose you have sales data in a CSV file in Azure Blob Storage. An ADF pipeline can extract this CSV, transform the data using a Databricks notebook, and then load it into an Azure SQL data warehouse. Using a schedule trigger, this pipeline can run every night at 2 a.m., fully automating your data workflow. To recap, pipelines are the containers for your workflows. Activities define the tasks inside pipelines. Datasets represent the data being processed. Linked services provide connections to external sources, and integration runtimes handle the compute and execution of activities. Together, these components make ADF a powerful tool for cloud-based data integration. Some best practices for ADF. Modularize your pipelines to make them easier to manage. Use parameters to avoid hard-coding values. Always monitor pipelines and set up alerts to catch failures early. Finally, optimize your integration runtimes for cost and performance to ensure efficient pipeline execution. ADF is used for a variety of real-world scenarios. Common use cases include migrating data between cloud and on-premise systems, performing ETL or ELT workflows, integrating data for analytics platforms, and automating repetitive data processing tasks. Its flexibility and cloud-native design make it suitable for modern data projects. ADF pipelines can scale to handle large datasets. Use multiple integration runtimes to parallelize workloads, partition data for faster processing, and optimize the execution of activities. Scaling pipelines efficiently ensures faster data processing and reduces costs. Security is built into ADF. You can assign roles and permissions using role-based access control. Use managed identities to allow services to authenticate securely, and configure linked services with secure credentials. This ensures that your data pipelines remain safe and compliant. To summarize, Azure Data Factory is a cloud-based data integration service that allows you to automate, monitor, and scale workflows. Its core components, pipelines, activities, datasets, linked services, and integration runtimes, work together to create flexible, reliable, and secure data pipelines. By understanding these components, you can design efficient workflows for modern data projects. Thank you for watching this detailed guide to Azure Data Factory architecture and components. I hope this video gave you a clear understanding of how ADF works and how to design pipelines efficiently. Don't forget to subscribe to ZoomInData for more tutorials, tips, and guides on data engineering and cloud technologies. See you in the next video.